So I will make a presentation that I entitled Towards CAPE-OPEN 2.0, and this presentation is, I was asked to give it as a response to Mark Stinchman's presentation at the CAPE-OPEN 2019 annual meeting, a presentation that you should be able to find on our website. These are my views. They have not been revised, approved in any way by the CO-LaN Management Board. And I just addressed what Mark addressed, plus a number of additional things that I wanted to state as well. So Mark addressed different points, like what are the changes in the computing landscape, the changes in the process simulation landscape, and as well as a number of pain points in the current CAPE-OPEN standard, which have been listed as either being in thermodynamics or in unit operation. What I would say first is about CAPE-OPEN 2.0 is that the scoping of a version of CAPE-OPEN has not often been done. It was made for the CAPE-OPEN 1.0, which was released in 2003, but the scoping didn't take place then. It took place when scoping the global CAPE-OPEN project, so it takes us back before mid-1999, so it's 20 years from now that real scoping of a version of CAPE-OPEN has been done. And indeed, scoping of 1.1 was never done for CAPE-OPEN, so 1.1. And as we have discussed a lot when making the proposal for versioning, this may have been quite unfortunate. I would like to say also that CO-LaN is known for slow progress on interface specification delivery. It's in fact no different from most standard development organizations, and also it has to be considered that CO-LaN is having less resources than most SDOs that we know of. So the slow progress is in fact relative compared to other development organizations and also the resources involved. Also, it should be understood that aiming too high in terms of scope calls for some dissatisfaction in the end if the goals are not met, and aiming too low makes the goal unattractive. So indeed, there is a need to find a compromise there. Also, there is a need for a time horizon. And well, my proposal is to make October 2025, which will be the last CAPE-OPEN annual meeting usually taking place before the end of the next duration period of CO-LaN. It could be, in fact, the target in terms of time horizon for 2.0. And indeed, because it is a good place to consider if CO-LaN has to be extended at that point. So let's go to what Mark mentioned in his presentation. First, about the changes in the computing landscape. Present is mostly single-threaded and future is multi-threaded. Indeed, single-thread is common because the architectures of most of the process simulation and modeling software that we are using and so considering is going back to the 90s and has been worked upon, reworked a little bit, but mostly the architecture is going back then. And also what needs to be seen is that when multi-threaded, some are then, most often it's not that many threads. Some side effects of different threads used by separate components, especially with respect to the Windows handle, which is needed in order to make the edit window pop up, has been resolved in COBIA phase 2. So it has been specified in CAPE-OPEN 1.2 in the new signature of the ICAPE utilities edit method, and this typically is a first step in considering different threads. Multi-threading is addressed by COBIA. There is threading models, which are mostly rules, have been developed by the MTSIG within phase 2. This needs to be refined in phase 3 because we have still some questions which are not definitely resolved. I would say that it has not necessarily an impact on the CAPE-OPEN 2.0 specifications, but still it will have an impact by saying how COBIA and then CAPE-OPEN is addressing multi-threading. Changes in the computing landscape. Future of process simulation is cloudy. Indeed, in the present time, it becomes progressively more cloudy. ProSim, AVEVA, ANSYS, COMSOL, and certainly others are present on the cloud with their process simulation software. It's both for evaluation purposes as well as daily calculations. Both situations can be encountered. But it should be said that user subroutines, as in terms of the proprietary user subroutines that this or that PME is allowing, plugins like CAPE-OPEN are not always part of the cloud offer made so far. This is due, at least in part, by the possible license issues which are encountered, and these license issues have not been resolved yet, and this may be part of the circumstances that need to be resolved. Do we need an additional CAPE-OPEN interface specification or a technical solution for CAPE-OPEN implementation to be developed? I don't know. Mark proposed a CAPE-OPEN API for the web in order to resolve that. I think the first thing to get really is to figure out if there is indeed a business case, which means end users wanting to do something and software vendors ready to implement. If there is a business case, in fact, letting CAPE-OPEN be usable through some cloud operations can be considered within the scope of COBIA Phase 2, which is still under definition, so there is still an open door there, and ends towards CAPE-OPEN 2.0. The business case can be, as I have heard it, an organization makes available on the cloud the unit operation A, which is a PMC in the CAPE-OPEN understanding, to its customers for use in any process modeling environment, such PME being on a given desktop or laptop or on the cloud, with no download of the CAPE-OPEN PMC being allowed by Organization X. Well, this kind of business case that I have been hearing about is just, in fact, a generalization of the case used in the virtual plant demonstration model, also named as the VPDM project, presented at the CAPE-OPEN 2006 annual meeting by PSC Limited, where it was defined as aimed to support arm's length inter-organizational collaborative modeling, allowing companies to make their models available in a strictly controlled manner to collaborating organizations with which they may potentially be competitors in different contexts. Or for sure, at that time, we were not really speaking of cloud-based process simulation. It was distributed computations, but, and I guess that a number of you around this virtual table were there in Cannes when this was presented, but it looks very much in an old-fashioned way like the business case that I heard, that I mentioned above. This business case led to a demonstration project only, what would make it more important today to lead us to invest in some additional resources. My thinking about the way forward on cloud issues is that end users, organizations, and software vendors have to develop relevant business cases as general as possible. It is not saying that Shell, Linde, or others are going to say, or yes, Pentec, Aviva are going to say, we are going to take this particular PME and or PMC and make use of this for that kind of use, but in a more general way. And also it is to manifest the intent to use the solution once preliminary design is available. My point is that there is no use for solution which is not implemented. The possible consequences of going forward on cloud issues and their solutions is additional delays in COBIA Phase 3 deliverables, additional budget for COBIA Phase 3 development, but also increase attractiveness of CAPE-OPEN because of pointing to cloud-based process simulation. Still, and Mark, I think, made the point also, performance could be an issue when considering cloud-based process simulation being distributed on a number of cloud servers between PMEs and PMCs, especially, I would say, for thermodynamics. Mark also addressed dynamics and equation-oriented modeling by saying that more dynamic and equation-oriented modeling in future than currently. Yes, I agree with that. It seems to be a trend that is beginning to form up. About equation-oriented modeling, it should be known that it has been considered from the start in the development of the CAPE-OPEN standard, which took place at the end of the 90s. As part of the numerical interface specifications, which were given in the CAPE-OPEN project, the same importance as thermal and unit packages. There was a numerical package. The conceptual design of the numerical interface specification was conducted by Imperial College, with in fact mostly people involved also in PSC Limited, so in GPROMS, with the definition of an equation set object to encapsulate system of equations, for example, of the type that Dr. Thomas talked about, and numerical solvers also were designed as specific CAPE-OPEN object to encapsulate solvers of many kinds, ODEs, DAEs, and so on. It has been implemented with sometimes some adaptations, at least in one commercial tool, GPROMS. I am pretty sure there were some adaptations compared to the original design that PSC put in the numerical CAPE-OPEN numerical interface specifications. It has been also implemented in a number of academic tools, EMSO in South America, KPOP at University of Aachen, and Diana at the Max Planck Institute, and the one which is still known to me as being active is indeed Diana, where you have now and then publications that are referring to the equation set object, which is used by Diana in order to move models from one application to another. What should be known about the status with CAPE-OPEN numerical interfaces? Nowadays, they are out of the scope given to COBIA Phase 2. So consequently, the CAPE-OPEN numerical interface are out of the CAPE-OPEN 1.2 version. Will they be in the scope of COBIA Phase 3 and consequently of CAPE-OPEN 2.0? Well, the current reasoning within Method and Tool SIG on COBIA is that there is no numerical special interest group to take care of numerical interface specifications, so there is no maintenance of these interface specifications. There is almost no implementation of such interfaces in commercial tools. And so there is no business case that exists for maintaining numerical interface specification within the CAPE-OPEN standard. Still, CO-LaN had a number of past activities around these numerical interfaces. For example, numerical interfaces were included in the original test suite. We have been talking about the new version of a test suite, which will be soon put to development. At that time, the reasoning regarding including numerical interface was that a test suite needs to cover the entire spectrum of CAPE-OPEN. Also, as part of the CO-LaN activities on numerical interfaces, the mixing of equation-oriented and sequential approaches was discussed about 10 years ago. And the point was to make black box model, classic unit operation models, usable in equation-oriented PMEs. This is already partly meant or supported or proposed in the current CAPE-OPEN unit operation interface specification, but that part of the CAPE-OPEN unit operation interface specification has never been implemented, or maybe partly in the AspenTech mixer splitter Visual Basic example, which has disappeared from the distribution of Aspen Plus and Aspen ICs now for a number of years. So, in fact, the current part of the unit operation interface specification needs to be extended in order to make it completely functional. And it was the purpose of the proposal made by PSC Limited to CO-LaN full members, like I said, about 10 years ago. Still, there was no follow-up by CO-LaN full members at that time for budgetary reasons, mostly. It is unclear if the design contained in the project proposal can be directly reused by CO-LaN, since the copyright is held by PSC Limited, and I have no information from PSC about that at that stage. Is there a lack of business case and of financial resources for further activities regarding numerical interfaces? Is it mostly the lack of a numerical special interest group to maintain sustained interest in numerical interface specification, which is putting numerical interface on the back burner of CO-LaN? Well, there was an attempt to create a numerical special interest group at the very beginning of CO-LaN. It was not successful. People were not really feeling as entering in such a special interest group. Still, I think there is a potential for a numerical SIG within CO-LaN with an expertise which exists in academics, in software vendors, and in end users. For example, in academics, Carnegie Mellon University, where indeed IP-Opt, for example, was made as a CAPE-OPEN MINLP solver. At the Federal University of Rio de Janeiro in Brazil with EMSO. For sure, there is expertise at PSC Limited, but also, I guess, at AspenTech, where you have Aspen Custom Modeler, and at Aviva, where there is also an equation-oriented process simulator, which is proposed. And I am pretty sure that at BSF, with Chemasim, which is an equation-oriented simulator, at Linde Engineering with Optisim or at Shell, there is expertise on numerics, and that could be put to use in a numerical SIG. But without a numerical SIG, I don't see any numerical interfaces in CAPE-OPEN 2.0. And this would have consequences for sure in getting dynamics and equation-oriented modeling being, in fact, supported in any way by CAPE-OPEN 2.0. Mark said that indeed more dynamic simulation in future than currently. This has to be supported somehow by CAPE-OPEN. In CAPE-OPEN there are presently at least two approaches to dynamic simulation that I can figure off. There is an interface specification that has been written for dynamic unit operations. It has been designed with operator training simulation in mind. And it has been prototyped in Indis Plus, at that time RSI, now it is called CORIS, and in PMCs that were developed at IFP EN. But nowadays there is no impact of that implementation of this interface specification on CORIS current business. It has not been implemented in any of the commercial and academic tools to my knowledge. So the question is typically, is there still a business case for that interface specification, or is it that the design has to be revised to make it more proper to be implemented? The other approach in CAPE-OPEN regarding dynamic simulation is the interface specification for differential algebraic equations. It has been implemented in academic tools, not implemented in commercial tools. And the question is there also, is there a business case for that, or should the design be revised? And this takes us back to the need for a numerical SIG. The interface specification for dynamic unit operations, as it is an activity that has been located within the unit special interest group. The activity goes back now to quite a number of years. It is an extension to the unit operation interface specification, so there is no real constraint with respect to the inclusion in CAPE-OPEN 2.0, since it is not a modification of the current unit operation interface specification. Nobody currently within Unit SIG is from the original design team. So the question that needs to be asked is this interface specification which is needed in order to address the dynamic simulation and equation-oriented simulation that seems to be needed. Also, where is the expertise out of CORIS and IFP-EN in CO-LaN, seeing that CORIS and IFP-EN are not anymore really into that. We have Kongsberg with their KSpice multipurpose dynamic simulator, which is in this field. We have also SIM Info System with simulator OTS system. Does it make for sufficient, in fact, number of people and a sufficient level of expertise? But mostly, is there a business case for changing the Unit SIG charter to include work on this specification? I think these are questions to be answered by the management board and also by any CO-LaN member who wishes to be part of this trend into dynamic simulation and equation-oriented simulation. Now I would like to address some pain points that Mark addressed. Pain points in thermodynamic PMC life cycle. He said nowhere to create an empty property package. For sure, a property package manager exists, but its functionality is too reduced for what Mark is asking for. There is a current proposal, and Sergey very nicely spoke of it in the ThermoSig activity report. There is a current proposal to address the issues that Mark mentioned, or at least most of them. It is a manager interface specification that would carry functionality defined nowadays for chemical reaction package managers in the chemical reactions interface specification, saying editing, saving, loading, preset management, and so on. This type of functionality would be made common to property package managers, to chemical reaction package managers, and what else? It is meant to be part of a CAPE-OPEN WAT.X and further. So I guess there is largely a response which can be given to the pain point that Mark mentioned. Perhaps not complete, but most of it. Property packages are inherently unsafe for multi-threading. Property package calculations are progressively made thread-safe. I would just report you to the KBC presentation. Extension of thread-safe models was mentioned. The underlying legacy software is often an issue, which is slowly reserved in terms of thread-safe. Mark points that the material object is a root cause of the pain points that he is mentioning, because the MO is used as a data container to store calculation results. The solution proposed by Mark is to make a property package a stateless object, no move of data in and out of a MO by a property package, and to move part of the complexity to the package manager. That this part is underway, this is partly underway by specifying the manager interface, but Mark requests more, for example, in terms of compound subsets. So Mark advocates for major changes in design of thermodynamic and physical properties interface specification. I would say that the current specification is widely implemented. A new solution is possible always. It needs to be fully specified. So it will mean much time to be allocated to that. This would be a major revision. And it could be a reason for success or failure of CAPE-OPEN 2.0. Who would be willing to implement the new solution in parallel or to replace the current solution? Software vendors have often showed reluctance to change because of the heavy development and maintenance cost. On this, we need to hear from software vendors. Any interface design has benefits and flaws, and I guess no new design will not have that. So it is always a compromise between these benefits and these flaws. Regarding other priorities on thermodynamics, I would mention the inclusion of the revised chemical reaction interface specification in the main thermodynamic and physical properties interface specification with a single phase equilibrium interface, which is already something defined in what you will have to RFC. Distributed property support needed for solids, for instance. TUHH made a proposal and implemented the interface specification in SolidSim. The design may have to be reviewed with also the question of any intellectual property issue with SPENTEC. There is also the issue of semantics of property package parameters, because no naming convention makes identification of parameters difficult. And also for the support for multiple point calculations in one call, which is something that came up as a use case for multi-cell unit operation models. Pain points on unit operations. Mark mentioned that there is a need of software to support classic unit operation in an equation-oriented environment. See part above on black box used in equation-oriented PMEs, the solution proposed by PSC Limited. This is actionable for CAPE-OPEN 2.0, but I guess with some limitations that needs to be addressed regarding property rights. Mark proposed also a real-time display of current condition. A complete use case is needed on that. But I see that possible implementation could be made in ChemSep and HTRI if consensus is made on this part. Other points on unit operation, CAPE-OPEN is looked upon often as a reference. At CAPE-OPEN 2019 annual meeting, there were presentations by CIFOS and DEXP. Discussions have been initiated by CO-LaN with DEXP. It is the point of linking a data model and interface model. Possible modification to the identification part of unit operation could be an answer, or at least part of the answer. So it would be more than an extension, so something that could be part of CAPE-OPEN 2.0. It is, my analysis is that it is a challenge because it's a new domain to be mastered. There are some benefits, immediate access to new stakeholders, some risk because we need to meet expectations from other standard development organizations. What could be CAPE-OPEN 2.0 in 2025? Thermodynamics, already a number of things are under development, the close integration between chemical reactions and thermodynamics, the manager interface offering enhanced functionality compared to what property package managers offer. Unit operation, the black box modeling support could be indeed a target for CAPE-OPEN 2.0. For equation-oriented and dynamic simulation, why not? Because a strong basis exists that could be ported to CAPE-OPEN 2.0, but there is a need for a numerical SIG to make it happen. There is also the aspect of opening to digital twin aspects, so what I mean by that, the SIFOS and the DXP part. Software engineering aspects that will need to be addressed are multithreading and cloud. That could be very well in the technical scope of COBIA Phase 3. Thank you for your attention.